For this particular lab, you're going to require not only your breadboard, but you're going to require a diode, a 100 ohm resistor, and 3 LEDs. When you're looking at the LEDs, pay close attention to the long versus the short lead for identification for polarity. And if you have cut them already, you'll notice there is a flat spot on one side of our resistor when looking down, and that also will indicate your anode versus your cathode. Okay, so the first step that we're going to do in our lab is we're going to do some testing to make sure that our diodes are in functional order. So we have our tester. We're going to turn our tester over to our correct setting. And on this particular meter, we have continuity and we have ohms. But on the next one, we have capacitance and we have the diode. So we're going to turn that to the correct setting. And right now it's got an F, which is telling me that's farads, which is capacitance. So I'm going to press my select. And I've got the arrow hitting the wall symbol to tell me I'm on diodes. I have to watch my polarity. So the first thing I want to make sure is that I have my black lead connected to my cathode, and then I'm going to take my red lead and connect that to my anode, and I'm getting approximately a little more than 6.6 volts. Now that we're back on our proper setting, I'm going to change this. I'm going to move this to ohms and see what the reading is, and we can see it's quite high. Again, let's change polarity. And again, we get an OL condition. We can also use our tester again on the arrow in the wall, and we can actually try to see if our LEDs work. The D obviously standing for diode. The next part of the lab is going to involve you using our function generator. Now, the function generator has a number of different features. One, you can change the frequency using the coarse and fine, and then we can also change the amplitude or the voltage by using the AMP switch. We're going to put our lead into our output of 50 ohms, and we're going to turn this on, and we want to start off with our 1K setting. So these are the frequencies we have. These are the waveforms we have over here. We have sine wave, triangle wave, and a square wave. So we're going to set it to sine wave. We're going to set it to 1, and we're going to turn this on. And right now it's putting about 216 hertz. So we're going to drop that down. And if we can't get it to a suitable amount, we can then lower it to 100 hertz. So we're at 80. So right now, this, even with the fine adjustment, is getting me down to really close to 54. We're going to be at 60 hertz. So I'm bouncing around pretty close to our 60 hertz, slightly over. And when I'm watching this, I can now take my meter and I can check my meter to see what my hertz is by setting my meter up to read hertz. So I'm going to move that to there. It's now reading hertz. I can now use the lead to actually measure my frequency. Now, if you look at the lamp at the top, even though I've applied an alternating current signal to it, you'll notice that it looks like it's steady. And I was going through, it's in series with this diode, which means this has to be anode to cathode to make that work. But my light is steady. And that has to do with the frequency that we're using. Watch what happens when I drop the frequency even more. I'm going to drop it down to 100. And the setting on my coarse and and fine frequency has dropped that down to about 6 hertz. I can drop that down as low. Let me go down to 1 hertz, and it's off. So it's coming off and on because it only sees half of our alternating current waveform. Now I'm up to 5. And the faster the frequency, the more it flickers. However, I'm going to reach a point where it's not going to be able to keep up. We're at 100, we're going to drop it down and see where it just starts to flash, where it's discernible that it's flashing. Below 60. And it's starting to kind of vibrate at around 36 hertz. It's getting more pronounced down at 27. All the way down to 18, 16. And now you can see that there's definitely a spot where it's almost completely turning off. So when you're doing the lab, you're going to be applying a sinusoidal wave to our circuit, and then you're going to observe it on our oscilloscope. To do that, we take the oscilloscope leads and we're going to put them into the circuit. Okay, so this is our oscilloscope, and we're going to go over a few of the functionality and features of it. Now the oscilloscope is divided up into your screen and in your controls. They use 2 different channels, depending if you're looking for a single signal or a dual trace. Each of them have a volts division, and there's one master time division. Now the volts division changes how many of these squares is relative to the amount of voltage applied. Right now, we're receiving about 7 volts from our signal generator, and it's giving us a perfect sine wave. The time division stretches that out so that each base of those represents a greater or smaller distance of time. So you want this to be about that size to watch what's going to happen when we put on a diode circuit to rectify the AC. Either that one or perhaps even we'll go up one higher, give it a nice sine wave. Now there's an auto reset button on the top, so when you first connect it up, you can give that a quick shot and it will recalibrate itself and give you the best overall picture. So then what we're going to do, right now I've got the circuit set up on my board, but I've left it open. I've not closed the circuit with a diode, so I'm going to put that back on. And now we're running through the 2 diodes as shown on the lab. And notice that the bottom of our sine wave is now being clipped. If I take that off, it goes back to our sine wave. This is relatively what we're looking for. We're looking for the sine wave to only be active on 1/2 of the waveform. Now I can move this up or down. This changes our center point. So if I wanted to have a second trace, which is the blue button, so if I take that off, you can see I'm no longer centered. So idyllically you want that line there, which says the 1 on the outside, on the center of your crosshair. And that gives you a more accurate image of what is taking place. Notice that if we have 1.5 squares up, we're actually chopping off the top half of that waveform. It's not coming down to the 1.5, so we're chopping off the top half of that waveform from our diode setup.